So let's look at this question. It is on work, energy, and power. So I'll read it through. A pile driver of mass 500 kilograms falls freely through a height of 1.5 meters onto a pile of mass 200 kilograms. Determine the velocity with which the driver hits the pile. If at impact 3 kilograms of energy are lost due to heat and sound, the remaining energy being possessed by the pile and the driver as they are driven together into the ground a distance of 200 meters. So we are asked to determine the common velocity immediately after impact. Then question number 2 is determine the average resistance of the ground. So let's see how we can go about this question. So you see the potential energy of the pile driver is converted to kinetic energy. Okay, so from potential energy to kinetic energy, that is for the pile driver. So we know that kinetic energy in this case is equivalent to, potential energy is equivalent to mgh, and kinetic energy is equal to a half mv squared. Now from this equation here, you can be able to get the velocity that the pile driver hits the pile. So we need to manipulate this equation here, of which velocity v will be equivalent to the square root of 2 gh. So already we had tackled this in class, and I believe you know how this is coming about. So from this equation here, we can get the value of the velocity. So we have g, so g is 9.81, and then h is given in this equation as 1.5. So it is 1.5 meters. So when you substitute that in the equation, we'll have the square root of 2 multiplied by 9.81 multiplied by 5, sorry, 1.5, 1.5 meters. Then we end up with 5.42 meters per second. So kindly go and work it out and find if this answer is correct. So that is the volume, the velocity with which the pile driver hits the pile. So that is equivalent to 5.42 meters per second. Then let's now look at the first part of the question, which asked us to get what you call the kinetic, let me go back to the question. The common velocity immediately after impact. So before impact, the kinetic energy of the pile driver is given by a half mv squared, and we say half times mass, of which in this case was given as 500 kilograms. There is the mass. So we substitute in this equation. So you have 500 multiplied by velocity, of which you've gotten in this first working, is 5.42 meters per second. Now when you work out this should be squared. So when you work out this, you'll get around 7.34 uh, kilojoules. But remember, not all this energy, uh, if at the impact 3 kilojoules of energy are lost due to it and sound. And so let's get the kinetic energy after impact. So to get kinetic energy after impact, kinetic energy after impact is gotten by, say, 7.34 kilojoules minus 3 kilojoules, and we remain with 4.34 kilojoules. So the pile driver and the pile together have a mass of so total mass of pile plus pile driver given us. So the mass of the pile driver is 500 plus the mass of the pile is 200. So this will give us 700 kilograms. That's the total mass. And these two possess kinetic energy, which is equivalent to 4.34 kilojoules. So we want to work out the velocity, the common velocity after impact. So how do we get common velocity after impact? So for us to work out this, we'll already have kinetic energy, which is equivalent to 4.34 kilojoules, and we equate that to a half times the total mass, which is 700 in this case, multiplied by v squared. So guys, we want to get the value of the v. So now in this case, we will have to get v, we'll say the square root of 2 multiplied by 4.34 times 10 raised to power 3 divided by 700. So 700 is the mass. Then you have these two, which is this one here. Now, remember there was a kilojoules. So this means that you would have multiplied this by 10 raised to 3. Okay, that is why you have 10 raised to 3 here. When you work out this, you should be able to arrive at 3.25 or so meters per second. So that is the common velocity with which that is the common velocity after impact. This is the common velocity after impact. So let's look at the second one in the next video, the second part of the question. So in the second part, we're going to look at the average resistance of the ground.